Hi everyone, welcome back to Firemind's Full Circle podcast. I've dragged in these two lovely fellas with me today. We're going to talk about coding in general and practices and the best way that people can get started, I think. I always say to you guys that we should always think about build systems as we're going between languages, for example, whether we're building applications or models or DevOps pipelines, whatever, it's all about build systems. And I always joke about, the eternal struggle between Python and JavaScript. So I think it's just a relaxed discussion to kind of take your ideas and just think of things back and forth, because again, I'm very much of the mindset where probably I'm longer in the tooth than you guys with touching different languages. It's always good to hear the approaches you take and maybe thoughts and criticisms about how I tell you everything's easy and it's just a Google away or a certain model question away, right? So I think that's what we do. So Jason, if you want to introduce yourself.
Yeah, hi, I'm Jason. I'm a cloud engineer. I've been working here for approximately 2 years now. I think slightly over more than 2 years. But yeah, I primarily deal with building applications, obviously in the cloud, and obviously we're focusing on kind of AI element of it now. Obviously, generative AI is such a buzzword, I guess, at the moment. So definitely working on those kind of projects. But yeah, that's kind of what I do day in, day out.
And who are you, Khalil?
Yeah, hi. Obviously, you said my name already. So my name is Khalil. Or if you come from an Arabic background, you can say my name as Khalil, which is the correct pronunciation.
Absolutely.
Yeah, Khalil Adib, and I'm data scientist at Firemind. I've been here for almost 1.5 years now. And so, yeah, like I said, I am a data scientist, but I do all sort of stuff from AI engineering, ML engineering, building pipelines, sometimes a bit of data engineering, sometimes a bit of cloud engineering. So a bit of everything. So, but my official title is data scientist. So here I am.
So then this is a good thing to start out.
Yeah.
When we first met, I explained to you that doing data science in a commercial environment is very different to academia. How have you found it? Because I've kind of pushed you into understanding cloud engineering, can we talk about build systems, etc. Has that met your expectations?
I think you are approaching it in the wrong way. It's not like data science against in the industry versus data science in the universities or academia. I think it is research versus industry, and then when you work on a research lab at a certain university or even big companies, because big companies, they do a lot of research, and then they do because they have a lot of money to fund stuff. So it will always be about we have to solve this problem. We are aiming to do a certain goal. We can fail, and most probably we will, but we will end up with some conclusions, and we have to write some research paper. But along the way, we have to do a lot of coding and building pipelines and stuff like that, which are not production ready. It's not their job to do production ready stuff. While what we are doing in here is we are starting, I would say, from the point where research works were done. We are taking, for instance, in the generative AI space, we are taking foundation model and pre-trained model, and even fine-tune. Sometimes we can fine-tune models as well and take it from there. And then we have to work on a way to make it meet the customer expectation, and then we have to manage everything on the cloud to make it basically available for everyone.
Yeah, and I think that's interesting. But I think what I always say to you, and again, Jason, you said this when you first joined here, there is a situation whereby a lot of, let's say, data science, data engineering, whatever, exists within notebooks.
Yeah.
But notebooks are not production ready, right?
Yeah.
So when we're thinking about build systems, it's how do you take the requirements, maybe experimented over in a notebook, and then convert it into, when we're thinking about AWS, for example, you could absolutely have a single monolithic Python script and run it on an EC2.
Right.
Sure. No problem at all, right? But we know not to do that.
Yeah.
We know to build out distributed systems where we then have to think about and dissect our notebook or script or monolith into maybe queues, into notifications, fanning stuff out. We had a discussion earlier this week about how we can think about the concept of running vector databases in memory,
right? But
distributing multiple requests using something like memcached with, I think there's a NumPy extension that allows you to do that. How have you felt this transition between you know, because you still use notebooks, I use notebooks, they're great to experiment on, but how have you kind of felt this kind of transition from, I no longer have this thing that's done, and actually there's something else that you can't necessarily touch, you kind of understand, but Amazon has, you know, 300 services, right? They're all distinct, they're all different, they have their own parameters. Some need encryption, you know, some need encryption in transit, etc. What has that been like for you?
Yeah, so like you were describing, we usually, as in the data science or AI or ML community, whatever you want to call it, we start with notebooks where like we do a lot of experiment, which is like, notebook is really powerful tool to do experiments because we can hold states in it and stuff like that. But always the next step is to deploy these stuff on cloud platforms like AWS to be specific. And doing this for 1.5 years, it's just like, I have the mentality, I would say, or the mindset of like, if I see now a code, I can imagine how I can break it down and then see like, this is the input, this is the output. How can I handle like error handling in this nice. Case? How can I let the user that about the status of the jobs? Like, for instance, we use DynamoDB a lot of time just to hold metadata or like keep progress with the states of the job and stuff like that. When to use SQS, for instance, because we want to queue the system, how to make the solution, I would say, less expensive, cheaper for the customer and stuff like that. So yeah, it's just changed my mentality of looking at things. So like now, if I see a website or any application, without thinking, I just start think about how can I replicate this, and let's say I want to build it from scratch. What would be the system design or ML system design around it and stuff like that? So,
at what point do you think that happened? At what point do you think you started thinking in a distributed hyperscaler approach?
You mean at what point? Like I have to mention the project or the time?
Like when you were working maybe, and you kind of thought to yourself, like it clicked to go, I'm dealing with state here. Yeah. It looks like I'm queuing it. It looks like I could distribute it across multiple tasks.
Yeah.
At what point did that finally click in your head to know that as you're building up almost that house of cards in your head, it's not just all in Python and variables and whatever, or other coding languages are available, but it was AWS services, for example.
So,
was it a project? Was it a time? Was it?
I would say both, because when I started, I remember like you just start smashing me with new projects like within my first 10 days, or like I was supposed to do like just training for the first month or whatever, but I started directly on the projects, and then to be honest, I found it really difficult because I remember my first project was like deploying R API, which is R is really difficult language by itself to work with, but now you have to write an API for R and deploy it on SageMaker. And then I gained a lot of experience specifically with SageMaker and with that project. And after that, I worked on different projects where like me and Jason, we built, we deployed, I think it was an object detection model and then we managed to actually deploy it on a Lambda, create a Docker image for that on a Lambda. So from that point, I started looking at the problem from a different perspective and try to just, like I said, break it down. That if we have, for instance, in step function, if we have a list of objects that we want to run the same iteration over it, now I can directly say we have to do like map state, because the map state will run the same Lambda, but the same code, the same function with different inputs, and then I can control the concurrency for that. I can control like even I can do batching with it. So yeah, I would say with time and projects, with time and projects, I start changing. This just changed my mentality.
Yeah, because you see the results.
Yeah.
And again, coming to you, Jason. So you know, I remember one of the first things you told me when you joined here was that data scientists would throw notebooks at you and say, make it into production. So again, you probably didn't have that eureka moment here. You probably had it at your previous place, right? But you worked a lot with Khalil. You worked a lot with myself again. So like, if we're thinking about that process of how do we help people understand this thing that they're trying to build needs to have that mix. And again, when I talk about academia, I'm saying, you know, it's fine to think about the notebook, but there's also then this entire iceberg of things you never thought you would touch, right? What are the approaches? What are the thoughts? What are the things you wish you learned when you started? I mean, again, it doesn't matter because you learn from failure, but
Yeah, so so coming at this from the kind of other side of things, obviously as an engineer, so I don't do the let's say AI ML portion of what Khalil does, right? And as you said, in my previous role, what I was ultimately given was just like huge amounts of just notebooks, and they would just kind of be like, pick and choose what you need to basically get this working. Wow. Right? So it's like they would give me what is essentially a data scientist brain dump on a notebook and be like, you know, this was what I started with, this is the output, and
figure out yourself.
Figure out, yeah, put it in a service that, you know, just makes sense to get it working. And obviously from that perspective, they wouldn't think obviously at the bigger picture. But what's really nice is that obviously with working with Khalil, and obviously what he's been saying is that he's already thinking about how to break down the problem, which is like super key for this, right? Because again, what's in a notebook means nothing to nobody until, you know, you can get it into a system that, you know, like a distributed system, like something that can actually be used, right? And so from very early on, if you can break down the problem, like Khalil was saying, you can start thinking about actually what happens to this bit of code beyond this notebook. And obviously the collaboration between the two roles becomes a lot easier, because then actually you can say, you know, this is best suited for this. You can have meaningful discussions, I guess, about how to best approach it. And because both teams, let's just say, understand what the end goal is, and they both understand that there could be different approaches, you can really basically hone in on what a good solution looks like, and you're not left with kind of, oh, here's just some code, do something with it. Whether it's right or wrong, you'll find out at the end, I guess. But yeah, having that kind of that collaborative approach between data science and kind of the DevOps engineering side, it's really refreshing. And again, it's not something that I was initially used to, but obviously doing more of these projects with someone like Khalil who kind of understands that is really nice.
One thing I always say when we're thinking about, I guess, distributed process management systems on AWS, I kind of think about two key pillars. One particularly, and again, if we're thinking asynchronous processes, right? So these aren't particularly APIs. This is something that is thrown in, and, you know, it could take over an hour, for example. Whenever I do, you know, interviews or questions with people, I always say, well, at what point do you go from Lambdas, SQS, SNS to actually, I'll put it in a step function? And then when we're thinking about state, at what point do we think about DynamoDB? At what point do we think Elasticache? At what point do we think things like Aurora, for example, or things on OpenSearch? Because there are so many. When we're thinking about this again from when you first started, or as you're dissecting those requirements maybe, or the solutions, and there's no right or wrong way, you know, it kind of almost doesn't matter. But something that I think is interesting is hearing how people think, I'll make a state machine and step functions for this, or actually I can probably get away with a queue and some lambdas, and I'll you know, you mentioned metadata and DynamoDB, or okay, you know, we had a discussion yesterday, I think, and we said, maybe that project might need a relational database because you're trying to do something that sounds relational. What comes into your mind when you're thinking about these things? How do you dissect these problems? How do you R&D them? What's the kind of approach you take?
So I think
both of you as well.
Yeah, so I think from my perspective, and again, I've been on a fair few projects where obviously, you know, you initially go down a path that you think it's a good solution, or at least you think it's the right services. Sorry, should I say? But then ultimately find out actually this isn't the best solution. So to a degree, you're right. It's a bit of trial and error, but once you've got past that trial and error phase, you then see that actually what the requirements for this customer. You know, the requirements this customer was asking for led to a solution that required these services, right? And then if you then have another customer that has a very similar use case, you don't have to go down that R&D path again, because actually you've realized this is a very similar use case. You know, there might be a few things here and there might be different, but ultimately it's like, you know, you can use the same solution and just modify, you know, configurations or whatever it is, right? So I think that's what I've seen a lot of. You go down a path and you try it. If it's not the solution that you're like aiming for, if that's not, you know, if it's not going to give you the solution you're looking for, you try a different path. But ultimately, we do find a solution, and then we use that as kind of almost like a template for the other solutions. But that's from my perspective of what I've seen deploying things.
What do you think, Khalil?
Yeah, so like you mentioned, there is no correct way of designing stuff. Like you can ask me to do or to design a system to host it anywhere, and then I can come up with a solution because based on your requirements, I said like, yeah, we should do 1, 2, 3, and then I'm saying that based on my experience, and then my experience came from, like Jason mentioned, from previous stuff that I did. So for instance, like we were talking yesterday about the relational database stuff, and then you just pointed me out about like you said that for you you can see that there is a relation between the data, so we should use relational database in this case. While because maybe I didn't work on that before, it didn't click in my head, but because you have the experience, you just gave me this hint. So like instead of changing it in the future, I can just like literally implementing this now. And then on the other side is like we have to know each service on AWS what it does exactly. So it will be really easy for us to choose a solution. Because like a lot of services in AWS, like basically you can run something on a Lambda and you can run the same thing on ECS, both, and then you can run it on EC2, right? And both, like all of them, they will give the same solution. But because we know like, oh, this won't take long, so we can run it on a Lambda, and then this can take long, but we don't want to manage a lot of services. We don't want to use EC2. We can use ECS. So like we have just to know about all the services and the props and cons for each one, and that's the way I would say.
And then a really interesting one is, as we're thinking about those kind of compute processes, you know, at the moment now you're writing a bit of JavaScript, and I always say that actually the hardest part of any of this is actually building for the front end, because people don't understand that on the front end, state management, it could last years if the browser's not refreshed or whatever, right? And I said to you, the hardest language is CSS, or anything that transpiles up to CSS, right? How do you feel about things like, and again, I always joke that Python and JavaScript are the same. I still believe they are the same. But now that you're writing JavaScript and you're seeing the slight differences, because generally they're still both functional, when we're thinking about deploying that code onto Lambda versus ECS versus EC2, where on Lambda it will be, you know, a short running function, and we have a lot of, I would say, framework decoration about how the code is run. ECS, I guess it's kind of long running, but it's still Dockerized again. Whereas on EC2, we're kind of starting bare bones and we have to get everything up. Still, what's your approach for, you know, local development, testing, thinking about libraries? I always talk about things like tree shaking again, really optimizing the code, and you can probably ignore over optimizing now, but thinking about the process management, the memory management, does that go through your minds as you're writing this code to try and be as efficient as you can? Are you thinking about things like hoisting variables, you know, function names, for example, trying to make it readable? You had the thing yesterday where we both gave you different solutions for chunking a list in Python, for example. At what point, you know, and I spoke to you actually about like, if you're using that string more than once, you turn it into a constant that's available. So how does that go through your minds as you're thinking? Are you optimizing as you're writing? Do you come back to it?
So my approach for that is like I would try to make it work first. Like even if the solution like it's really really bad, is really slow and stuff like that, I just make sure that it works. And then the step 2 is to actually make it better, I would say. And then to make it better, because I would say I fairly have like good understanding of the data structure, and any like big data structure is data structure. There is no like specific one in Python or JavaScript or something like that. So for instance, I'll just give an example in here, like when you have a list, and then you want what item you want to access at each time, you can use, for instance, dictionary, because when you want to access something in dictionary and then you know the key, the time complexity, I'm going into details now, but like the time complexity for this is like called O1, which is that's how they represent the time that you need to access something. While if you want to access the last element or you want to append a last element to a list, you have to go through all the element in the list and then append to the end. So you will basically your code will depends on the size of the items that you're working on, while in the dictionary it is like constant time. So that's step 2. So like I just make sure I don't read the same thing multiple times. I store the stuff in the correct data type. and then I would say I would add a bit of logging, so it will, if anything went wrong, I can see why and where exactly. And what else in my head? I would say, like,
I mean, I think it comes down to what good is fast and efficient if it doesn't work, right? That's the
or
way
you
I
can't read it.
Or you can't read it. Yeah.
So one thing is I would like to mention is like while like, because I've been working with AWS services a lot of time now, and then one thing I like use a lot when I deal with loading data and or uploading or loading data from S3, I use like multi-threading, because like if you just want to do like sequential loops, because I use Python a lot, right? So if you want to load like 100 item or 1000 item from S3, and you want to do some stuff with them and stuff like that, if you just waiting for each one, load it and do whatever you want, it will take ages, especially if the files like more than, I don't know, 1 meg or something. So I use multi-threading to load all of the files, save them in a place where like I can make sure that I save each one under a different UID or something, or different ID or job ID, and then I it will take literally 1 or 2 seconds. While if I want to wait for the whole thing, it will take the time that I have to wait for each file times the number of files. And then the same thing when I want to upload something to S3, right? So and then like JavaScript is much better than Python in this, because it has this async await and asynchronous calls, where like I don't have to wait for this. I can just let it run and that's it. But if I want to translate this to Python, my way of doing it is just like using multi-threading and multi-processing, which is really cool, I would say. And then even I remember one of the projects that the customer were asking about how can I make it faster, and then we were using Python obviously, and then I remember we were running ECS tasks, and literally I did this, and then like we had like I think more than 1 minute different in time. In 1 minute for the customer, it was like really big big time.
I think people forget, I was going to say really quickly, that people forget even Node and Python, these are single thread processes. So people will deploy them to, even Lambdas that support multi-threading and wonder why it's still slow. Sorry, Jason, I cut you up.
No. It just reminded me. There's a funny story when I first started and I was new to AWS. I was working with a data scientist who was also kind of new to the kind of whole ecosystem of things, and we were building some machine learning code for something. I can't remember off the top of my head what it was, but we just weren't familiar with Lambda and ECS and all these other services at this point. And I remember they tasked us to build this thing and get it deployed on AWS, and the data scientists wrote all this code, and then lo and behold, Lambda runs out, like times out at 15 minutes. And we're like, oh, so we can't actually run this code in a 15-minute time span. It's a long running bit of code. So we had the great idea of, well, let's just break the code down and checkpoint it every 15 minutes to make sure that thing was running. Had we have known ECS is just basically the same thing, but you can run it forever, I think we ended up with like 7 different Lambdas.
Wow.
For that one bit of code we were trying to run. And again, he was like clever enough to actually break it down in that way. But it just makes you think, right? Like if you don't know the services you're dealing with, you don't know that probably could be a better solution, right? And obviously in that scenario, it's quite funny because one ECS task would have solved our problem instead of we ended up deploying 7 Lambda functions, right? But again, that was obviously down to naivety, and we're all very like new to the whole, the whole space in general. But yeah, I think that's why it's so crucial to understand the services you are working with. And like Khalil said, it's like the code could be, you need to get the code working and then ultimately find a solution that will fit what you're trying to achieve in that regard. But yeah, sorry, it was just a funny story that come up.
Makes a lot of sense. So then in terms of like closing remarks, if you could give yourselves advice when you first started, what would those 20 words be? If 20, maybe less. Read the docs.
Yeah, I think it's funny, right? Because I think we laugh about it, but it's actually if you can get through the docs, they are very useful.
Yeah. But when you're under the stress of this is your first project, the first commercial gig, and you're having to do stuff, it's never that simple, right? No. So
I think, and again, this is something you've preached since I've joined, and I never really understood it until I understood it, which was fail fast.
Yeah,
absolutely makes sense, because don't try and perfect anything. Like just run at it head first and see what you can do, and then build on top of that. I think that is like again, initially it just never made sense to me that, oh, why would you want to just make it break immediately? But actually, it's a good approach, because I think, like I said, in the world of like AI ML, everything's a lot of grey, right? It's not black and white, so you're not going to know until you do it. So don't get, I think, too hung up on a lot of things, and just try it, see what works and see what doesn't, and then move on.
Nice.
For me, I would say, because usually I tend to get stressed when things are not working with me, so I would give myself an advice with like, don't stress, just it will work. And I would say, don't be afraid of asking questions, especially from like like more expert people, because they will definitely help you. So because for me, I was like, I don't know, like I don't like to ask a lot of questions, but because I like to figure stuff myself, but at the same time, to save time and to not waste company's time or even my time, I have to ask question to get things done fast, I would say. And like Jason said, just read the docs. Even though sometimes the docs, they can't be like super clear, but if you just go through the whole thing, like you would definitely find like the information that you're looking for.
Well, I mean, I have a personal vendetta against the AWS v3 JavaScript docs anyway. I'll find you a reinvent.
Yeah.
And but yeah, I think I'm really glad you said that. Fail fast, absolutely. I would get that tattooed on my forehead, like absolutely correctly. And like, yeah, don't panic. I'd get that tattooed on my forehead as well. And I think, again, we've all been juniors, and I don't think it's a pride thing. I think it's almost a worry thing. But I hope that, we here, but also people everywhere, give a nurturing environment that you're kind of okay, and it's okay to kind of take that approach, right? And I always say it's much better to just go, oh gosh, I can't go any further here, and we have to do something about it, than just keep going, right? Because then you just go into like a zombie state and nothing ever happens. No, it makes sense. Thank you for joining me, guys.
Thank you.
We smashed our lunches quickly to do this, to do this very ad hoc. Thank you again for listening, and see you guys again soon.
Thank you.
Thanks.
Thank you.
Thank you.
Bye.
Bye.